All right, so in this video, we're going to analyze log base 3 of x and its graph. So one thing is, if you're not sure what to do with this thing, if you just suck with logs, then try thinking about its conversion to exponential form, which would say 3 to the y equals x. And this right here, if you think about it, the inverse of it is going to be 3 to the x equals y, which we've already analyzed. So if you know what 3 to the x equals y looks like, then really you should know what its inverse looks like, which is this log over here. And 3 to the x equals y is a pretty basic looking exponential like this. So remember, inverses, you just reflect across y equals x. You're going to get a picture that looks like that for the log function. So a point that we know is on the original, on the 3 to the x equals y, all of those go through 0, 1. And then since it's 3 to the x, this would go through 1, 3, which means on our log function, it's going to go through 1, 0 and 3, 1. And in the exponential, we had an asymptote of y equals 0. So on the log, we have x equals 0 instead. Okay, so really, if I erase all this stuff, that's the graph of y equals log base 3 of x. So some other ways to kind of come up with that. Let's look at general patterns. So y equals log base b of x. So all these graphs have certain things in common. First, you can always convert to b to the y equals x. And remember, b, when you have b as the base in an exponential function, we restrict b to be positive numbers. So b to positive numbers. Because if it was a negative number to the y or to the x, you get these messed up graphs that keep bouncing between positives and negatives. So it's customary to restrict b to positive numbers only. Which means if this b is restricted to positive numbers, that b is always going to be a positive number too. We know that just by looking at this graph over here, the domain is only positives. We got a vertical asymptote at x equals 0, and we know that the range is all real numbers. So over here, when I'm talking about my general function, those all have the same properties too. X equals 0 is always your vertical asymptote. Your domain is always going to be just positive numbers. And the range is always going to be all real numbers. And then sometimes that changes, you know, the vertical asymptote, the domain, the range, or the range doesn't change, but the vertical asymptote and domain can change depending on whether or not you stretch and shift this function around. Let's see. Oh, one other thing. So a couple of points that go through this general log function. Well, since we can convert this to b to the y equals x, you know that anytime y is going to be 0, x has to be 1. So this always goes through the point 1, 0. When x is 1, y is 0. And then another point that it's always going to go through, when y is 1, right here, when y is 1, then you get b equals x. So when x is b, y is 1. So anytime you have to graph a log transformation, start with a parent like that, and start with these 2 points and that vertical asymptote, and you can figure out everything else about the function just by applying all those general point methods that we've talked about for other functions. Okay, hope that helps.